we have here a system of equations. Okay, I'm talking about this guy. A system of equations just means two equations, and typically it'll have two variables. But, I mean, it could have 3 equations, 4 equations, 5 equations with more variables. That would also be a system. But this one is nice. It's just 2 equations, 2 variables. And I want to know, when might it have no solutions? Under what conditions would it have no solutions? And to answer this, I'm going to refer to this old guy. Remember y equals mx plus b? Where have you seen that before? Well, you should be thinking about a line, right? This is y equals mx plus b. That's what that means. M is the slope, b is the y-intercept. And we call something a solution when you have 2 lines that intersect. Okay, this right here would be my solution. It's where the x and y values are such that those 2 lines overlap. Now, there is a case where you don't have an intersection. It's a very special case. It's when the 2 lines are parallel. They're never going to cross. So the question here is, if the 2 lines are parallel, then we have no solutions. What would it take to make the 2 lines parallel? Well, let's figure that out by turning these 2 equations into the line-intercept form that we're familiar with. Okay, I want to take each one and rearrange it into some kind of y equals mx plus b. So the first one, I'm going to say, great, 6x minus 4y equals 7. I'm going to add 4y to the other side and just rearrange it a little bit. Okay, so I bring 4y over to this side, bring my 7 over to the other side. So now I have 6x minus 7 equals 4y. Divide each side by 4, and let's see what we get. 6 over 4x minus 7 over 4 equals y. Can we rearrange that a little bit? That might make this easier. So we get y equals 6/4 x minus 7/4. Okay, great. That's equation number 1. Let's put a box around that guy. Now, equation number 2. Let's do that guy. And I'm going to move this over here just to make some more room. Let's put equation number 2 on the right. So equation number 2 says 3x plus a times y equals 1. Rearrange it a little bit, and we get a times y equals negative 3x plus 1. And that means I can divide each side by a and get negative 3 divided by a times x plus 1 over a. Okay, that's this equation in its slope-intercept form. So there's the 2 equations, and remember what it takes for 2 lines to be parallel. They have to have the same slope. Okay, when you have the same slope, that means no solutions, because they're parallel, they're never going to intersect. So where is the slope the same? Or in other words, where is 6/4 equal to negative 3 over a? Well, we can solve this. This is not a hard equation. Multiply both sides by a. See what that does? It cancels out the a's. Multiply both sides by 4. Now I cancel out the 4's. So what we have here is 6 times a equals negative 3 times 4. That's negative 12. And that means a equals negative 2. This produces no solutions in my system of equations. Take a look here. Yep, there it is. A equals negative 2. And if you wanted to solve this algebraically, that might be a fun method too. Plug a equals negative 2 into this. And then try to convince yourself that what we're really producing here is 2 very similar equations with a different y-intercept.